Welcome back, and we're going to pick up right where we left off with the last one. If you remember, in the last segment, we learned how to find the number of valence electrons that an atom has. And we said that this was going to be very important to figure out how they form bonds, interact, make new compounds. And so we're going to look at something called the Bohr model. The Bohr model, sometimes known as the solar system model, looks at these electron or energy shells and places the electrons. So if we remember from last time, how many electrons can fit in the first energy shell? So we're talking like hydrogen and helium. Well, in that case, there's only two, and they're kind of the exception. Once we get to the second and third energy level, where most of the elements that we're going to be looking at, the octet rule takes over, and we're looking at 8 electrons. Because if you remember back 2 or 3 videos ago, we talked about there's really 4 elements that are going to be super important for biology. And what were those 4 elements? If you remember, there was carbon, hydrogen, oxygen, and nitrogen. And actually, all of those only get as far as the second energy level. So that's kind of where we're going to kind of limit where we get to. I've got one here, magnesium, that goes to the third energy level, but we'll kind of leave it at that. So if we look at hydrogen right over here, how many valence electrons does hydrogen have? And if we look at the diagram, we can see that the valence electrons in this case equals 1. So is it stable in this configuration? Not particularly. It would like to gain a second one if it could. So if it could gain a second one, it would, and it would become more stable because its outer shell would be full. And if it does that, it just gained a negative charge, so this would become hydrogen minus, it would become an ion. Now helium, the next one over, has how many valence electrons? Well, we can see from that one, helium has, whoa, hang on a second, 2 valence electrons. Sorry about that. That kind of went, the marker went crazy. And let's see if I can, there we go. And we're back to there. So helium has 2 valence electrons, and it's stable as is. Lithium has 3 electrons. And we can see the first 2, here and here, go towards filling up the inner shell. But once that's full, the next electron, in this case the third one, has to go to the second energy level. So even though it has 3 total electrons, it has 1 valence electron. So in that respect, it behaves a lot like hydrogen does, because they both have 1 valence electrons. Now magnesium has 12 electrons. And as we go through, we can see 1, 2. The first 2 go on the inner shell. So we have 10 left. 2, 3, 4, 5, 6, 7, 8, 9, 10. We put 8 on the second shell because that's all that it can hold. So we've used up 10 of the 12. So that leaves us 2 electrons to put on the third energy level. So magnesium in this case also has 2 valence electrons, very similar to, or identical to what helium has. Okay, so here is a diagram that shows the Bohr model. So again, we've got the nucleus in the middle with the protons and neutrons, in this case shown as red and yellow, and then we've got the electrons in shells orbiting around that nucleus. So if we look here, we've got, I'll make these bigger, so here's the Bohr model of a carbon, and let's see if I can make this one smaller, sorry about that. And here we go. I'll make this one bigger. So when we look at a carbon atom, carbon has 6 electrons. So how many electrons would go on the inner shell? Well, we can only fit 2. So we've got, in this case, let me get red, 1 and 2. So there's 2 on the inside. And that leaves us 4 to go on the outside. So it would have 1, 2, 3, 4 valence electrons. I'll make this one smaller, and let's make this one a little bit bigger. And so now this one's not labeled, so let's take a look at it and see what we might have here. So how many electrons do we have? 1, 2, 3, 4, 5, 6, 7. So in this case, we've got 7 electrons. So that would mean that we have 7 protons, and it's a little bit harder to see, but if you count in the middle here, 1, 2, 3, 4, 5, 6, 7. So that means we have nitrogen. How many valence electrons does this one have? Well, in this case, we have 2 on the inner shell. That leaves 5 on the outer, so nitrogen would have 5 valence electrons. So 2 different examples of 2 different elements that have a different number of valence electrons. Okay, so now let's try to draw a couple. So calcium is the first one. So if we look at calcium here, calcium has an atomic number of 20. So as we've said before, a quick reminder, that means that's the number of electrons and the number of protons. So we've got 20 electrons to draw in for this. So let's take a look at that and go through, and let's use black for that one. And let's start in the nucleus, and we'll go calcium. And let's put our first energy shell in. How many electrons can we fit in there? Well, there's only room for 2 because they're both negative. They repel, so they don't like being in a small space. So we started with 20 electrons. We just used up 2, so we have 18 electrons left. Okay? So now we put a second energy shell. How many electrons can fit on the second energy shell? Well, we can fit 8. So let's go 1, 2, 3, 4, 5, 6, 7, 8. So we've just used up another 8 electrons. So we have 10 electrons left. Let's make that a little bit nicer. 10 electrons left. Well, where are they going to go? Well, let's add the third energy level. And how many electrons do we say could fit at the third energy level? Well, another 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that leaves us with 2 electrons. Well, I said we weren't going to go past the third energy level. I guess I lied a little bit. So let's put the fourth energy level. And how many are going to go there? Well, I'm going to change the color on these because these are going to be our valence electrons. So we have 1 and 2. So we have 2 valence electrons for calcium. And there's the Bohr model of that. And last one we'll do, let's look at aluminum. So again, aluminum has how many electrons? Well, we can tell from the atomic number that it has 13 protons, so there must also be 13 electrons. Let's start the same way. Let's have aluminum. How many are going to go in the first shell? Well, we can only fit 2. So 2 of them are gone. That leaves us with 11 electrons. Let's go to the second energy shell. How many can fit there? That's a pretty good circle. 1, 2, 3, 4, 5, 6, 7, 8. Let me get rid of this if I can. There we go. So we have 8, which leaves us with 3 electrons. Well, that means we're going to have to add the third energy level. And let's add 3 electrons. 1, 2, 3. So aluminum has 3 valence electrons, and this is how we represent the Bohr model of the atoms. And Chemistry Cat is back, and I'd tell you a chemistry joke, but all the good ones are gone. Thanks again, and we'll talk to you soon.